Every radio set works because electric charge can move through a circuit. That movement is called current. To make current flow, there has to be a voltage across the circuit. Voltage is the electrical difference between 2 points. The circuit also has resistance, which controls how much current flows for a given voltage. These three ideas, current, voltage, and resistance, are the starting point for basic electronics, and they appear again and again in amateur radio, in power supplies, transmitters, receivers, antennas, and safety questions. So before getting into radio waves, tuning, or antennas, this episode starts with the basic electrical quantities the ASOC syllabus expects you to know. In the previous episodes, we covered the amateur radio application process, eligibility, forms, documents, fees, and the license pathway. That part helps you apply. This part helps you understand what the exam is asking. The ASOC syllabus begins with basic electricity and electronics because radio is an electrical system. A transmitter, receiver, power supply, microphone, amplifier, antenna tuner, and even a simple coaxial cable all depend on these same basic ideas. If current, voltage, and resistance are clear, the rest of radio becomes much easier to follow. Current is the flow of electric charge through a conductor. In most wires, the moving charges are electrons. But in circuit diagrams and exam questions, current is usually shown as flowing from the positive side of a supply to the negative side. This is called conventional current. The unit of current is the ampere, written as A. The symbol used for current in formulas is I. So if a circuit has a current of 2 amperes, it means charge is flowing through that circuit at that rate. A small current may run an LED. A larger current may run a motor, a transmitter, or a heater. If the current is too high for a wire or component, it can cause overheating. That is why current is not only an exam topic, it is also a safety topic. Current does not flow just because a wire exists. There must be a difference in electrical potential between 2 points. That difference is called voltage. Voltage is measured in volts, written as V. The symbol used for voltage in formulas is also V. A battery provides voltage between its 2 terminals. A power supply does the same. When a circuit is connected, that voltage can cause current to flow. A useful comparison is water pressure. Pressure can make water move through a pipe. In a similar way, voltage can make electric charge move through a circuit. The comparison is not perfect, but it is useful at the beginning. More voltage generally means more ability to drive current through a circuit, provided there is a complete path. Resistance is opposition to current. It controls how much current flows for a given voltage. The unit of resistance is the ohm, written with the symbol O. The formula symbol for resistance is R. A low resistance allows more current to flow. A high resistance allows less current to flow. For example, a thick copper wire has very low resistance, so current can pass through it easily. A resistor has a chosen resistance, so it limits current on purpose. Resistance is useful. Without it, many components would draw too much current and fail. In radio equipment, resistance appears in many places. In circuits, cables, dummy loads, controls, and measuring instruments. Current, voltage, and resistance are connected by Ohm's law. For a simple resistor on steady direct current, V is equal to I multiplied by R. That means voltage is equal to current multiplied by resistance. The formula is V is equal to I multiplied by R. The same formula can be rearranged. If you want current, I is equal to V divided by R. If you want resistance, R is equal to V divided by I. Here is a simple example. If a 12-volt supply is connected across a 4-ohm resistor, the current is 12 divided by 4 is equal to 3 amperes. So the circuit current is 3 amperes. This is one of the most important calculations in basic electronics. For the ASOC exam, You should be comfortable with the three forms of the formula. V is equal to I multiplied by R, I is equal to V divided by R, and R is equal to V divided by I. Ohm's law is very useful, but it must be used correctly. It works clearly for resistors where voltage and current have a simple relationship, but not every component behaves like a plain resistor. Capacitors and inductors behave differently, especially in alternating current circuits. In AC circuits, the opposition to current is not only resistance, it can also involve capacitance and inductance. That later topic is called impedance. For now, remember the basic rule. For a resistor on steady current, use Ohm's law. Current, voltage, and resistance are the first pieces of the circuit, and Ohm's law connects them. But a radio needs more than a resistor. In the next episode, capacitors and inductors show how a receiver can favor one signal while the others fade into the background. If Ohm's law feels clearer now, like the video, share it with someone studying for their license, and subscribe to Calling CQ. Tap the notification bell so you never miss an update, then choose the next video on screen. See you on the air.